Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches so far for today's session. So Jogipet branch, Alwal KTS, Indresham, KTS Gudimalkapur, KTS Vani Block, Medchal, Masterminds Falaknama. For today's session, as you can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Today we are going to start a new chapter, which is the syllabus for test 6. Test 6, which is on 30th December. Right. So today we are starting the syllabus for that is session number 1. So we completed the chapter light concepts the last class, which is the syllabus for the test 5, which is to be conducted, which is scheduled for yesterday, that is 25th November. Now we are moving to the next chapter with the syllabus for test 6, which is scheduled on 30th December. So next maybe we will get 4 to 6 sessions to complete the chapter electric current. What chapter? Electric current. Very, very important topic in physics, because we cannot imagine our life without current. Right? Correct or not? In olden days, we used to live with the natural current, that is sunlight. But after discovering this electric current and various electric appliances, we are habituated for the luxury life without bulb, without fan, without AC, without mobile phone charge, right? Without geyser. Without these all electrical appliances, we cannot imagine also our life. Such a wonderful information is there about the electric current. But before knowing about this, we should know what is the prehistory of electric current. Right? Means already we learned, you might have learned in 6th and 7th classes. So this electricity is observed from last 2500 years back. When 2500 years back, a Greek philosopher, Thales, name of the scientist is Thales, who introduced the word electricity. Introduced the word electricity from a Greek word, electron. Electron is a Greek word from which the word electricity is derived. Right? So this electron means in the Greek, it is a type of stone called amber. Amber means it's a sky blue colored stone. That is, the stone is known to be a name as electron in Greek. So that word is given from that electron, it come to electricity. Right? This is a total prehistory of electricity. But what observed is when the Thales used to have amber stone with a fur. Fur is animal hair. When amber and hair are rubbed with each other, what they observed is there is a charges in both bodies. Then from that observation, he came to know that there are 2 types of charges. Charges are of 2 types. Number 1, positive charge. Number 2, negative charge. So like that, the study started 2500 years back. It has continued by so many scientists. After Thales, so many scientists came into the field, Ampere, Gilbert, and so many other scientists, Faraday. They started studying about the basics given by the Thales. And they developed the electricity. And till today, we are enjoying a lot of information about the electric current. Right? So this is the basic prehistory of electricity, which is started 2500 years back. Okay. Now we'll move to our original topics. Right. Now you can see here. Introduction of electricity. what we are going to discuss in the next classes. First point is electric current and electric potential. The second one is Ohm's law and factors affecting the resistance. Third one is chemical effect of electric current, heating effect of electric current. So these are the four important synopsis, four important topics we are going to discuss coming 6 to 8 sessions. That is in the month of today to entire December. So all these topics will cover in our examination, which is on 30th December, right? So before that, when we start the synopsis 1, it contains the two important concepts, electric current and electric potential. Electric current and electric potential. So introduction, already I gave for you. In the modern age, electricity is very important in our daily life. It is the most widely used form of energy. So most of the villages, most of the houses, most of the industries, they use the electricity more for their production. So that's why it is called as mostly widely used form of energy compared to others. So without electricity, life becomes difficult and we cannot use our daily gadgets like fan, light, air conditioner, washing machines, and computers. These gadgets makes our life easy. In this chapter, we discuss more about the electricity and its effects. Right? Do you agree or not? So you cannot do any work without these gadgets, electrical gadgets, because they make our work very easy. So to make our work very easy, we are ourselves, we made the gadgets and we are using the current for running the gadgets. So we learn in this chapter more and more about what is electricity and what are its effects. So before that, let me show you one video. First watch the video, then we'll go for the more details about the electric current and electric potential for today. Right? Okay. So just keep watching the video for knowing more about the basic concepts of electric current.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be discussing electrical current. We'll be looking at what is current, the different types of current, how to check the ratings of your electrical devices, as well as how we use safety features to save you from being electrocuted.
Yeah, general video.
Current is the flow of electrons in a circuit. To use electricity, we need...
What is the current? Current is flow of electrons, right?
Electrons to flow in the same direction around a circuit. We usually use copper cables to form the circuit because the atoms that make copper have a loosely bound electron in their outermost or valence shell, which is free to move around inside the metal. This free electron is very easy to move, which is why copper is so popular. It's so easy to move that it will naturally just move to other copper atoms by itself, but this occurs randomly in any and all directions, which isn't useful for us. For us to make use of this, we need lots of electrons to flow in the same direction along the circuit. We can then place things like lamps in the way of these electrons so that they flow through it and then they generate light and heat, etc. To do this, we need to force the electrons to move, and we can do that by applying a voltage. Voltage is the pushing force. It's like pressure in a water pipe. The more pressure we have, the more water can flow. The more voltage we have, the more electrons can flow. We've covered the basics of voltage in detail in our previous video. Do check that out, links in the video description down below. So we need a lot of electrons to flow along a circuit and through our lamps to get them to shine brightly. However, the cable and lamps can only handle a certain amount of electrons passing through them. Just like a pipe is rated to handle a certain amount of water passing through it, or a certain pressure. If it exceeds this, then the pipe will burst. Likewise, if too many electrons pass through the cable or the lamp, then they will just burst or burn out. We refer to the flow of electrons as current, and we measure this in the unit of amperes, although you'll usually just hear people say amps. This is represented with a capital A. For example, this fuse has a 3 and a capital A, which means it's rated to 3.
You can see everywhere the representation. 3A indicates 3 ampere. Current is measured in the name of the scientist, ampere. That is, current is flow of electrons or flow of charge.
Amps of current. We'll look at how we use fuses later on in this video. If you look on the plugs of your electrical devices, you should find labels from the manufacturers which tell you what the product is designed to handle. For example, this laptop charger tells us that for the device to work, it needs an input of between 100 and 240 volts and 1.5 amps of AC or alternating current. The charger will then convert this to give an output of 19.5 volts and 3.3 amps of DC or direct current. AC and DC are different types of electricity. The plugs in your homes will provide AC or alternating current. In this type, the electrons do not flow in a continuous loop, they instead alternate between moving backwards and forwards, just like the tide of the sea. Your electrical devices like laptops and mobile phones will use DC electricity or direct current. In this type, the electrons do flow in only one direction, much like the flow of water in a river. We transport electricity from the power stations in AC alternating current and send this to our cities and homes. We use AC here because it can be transported very efficiently and over much greater distances than if we were to use DC direct current. We can also very easily increase or decrease the voltage using simple transformers. We've covered how transformers work in our previous videos, links down below for that, do check them out. We mostly use DC direct current in the circuit boards of small electronic devices like laptops, mobile phones and televisions. That's because DC is easier to control and allows circuits to be smaller and more compact. Many appliances will use a combination of AC and DC. For example, a washing machine will use AC for the induction motor, which is used to spin the tub with the clothes in. But the circuit board, which controls the settings, the lights, the timers, as well as how fast the motor spins,
daily or regular how to use this that she explaining here.
will use DC power. We can convert AC to DC using an inverter. This is extremely common in electronics. We've covered how inverters work previously, links down below if you want to watch and learn about that also. People often refer to a river or the tide of a sea as having a strong current. It's very similar to electricity. A river with a lot of fast-flowing water is said to have a strong current. The same with electricity. A cable with a lot of electrons flowing through it has a high current. A river is able to handle a certain amount of water flowing through it. But if more water enters than the river can handle, then the river will burst its banks. The same with electricity. The cable will burst and burn out. Therefore, manufacturers need to be able to test cables and lamps to find out how much current they can handle. We also want to be able to see how much current is flowing through our circuits, as well as being able to calculate this. We can measure this using an ammeter, and we measure the flow of current in the circuit using the units of amps. So what is an amp? 1 amp is equal to 1 coulomb, and 1 coulomb is equal to approximately 6,242 quadrillion electrons per second. What does that mean? Another way to look at this is that to power this 1.5 watt lamp with a 1.5 volt battery, approximately 6,242 quadrillion electrons need to flow from the battery and through the lamp every second for the lamp to stay on. If we reduce the voltage, then less electrons will move and the lamp will become dimmer. If we increase the voltage, then more electrons will flow and eventually the lamp will not be able to cope, so it will burst or burn out. So to measure the current in a circuit, we need to connect an ammeter in series so that the current flows through it. Think of it like a water meter. The water needs to flow through the water meter for us to know how much water is flowing in the pipe. Likewise, we need electrons to flow through our ammeter so that we know how much electricity is flowing in our circuit. Instead of using an ammeter, we're going to use a multimeter, as we can do a lot more with this device. I'll leave some links down in the video description where you can pick up a good multimeter cheaply. I highly encourage you to get one of these for your toolkit. They're pretty cheap and are very useful. If we connect a lamp to a battery in series, then we can measure the current using a multimeter by connecting it in series. If we connect this 1.5 volt battery and this lamp, which has a resistance of 1 ohm, then we get a current reading of 1.5 amps, which means 9,636 quadrillion electrons are flowing through the lamp every second. Because it's in series, all the electrons in the circuit are flowing along the same path. So that means we can move the multimeter to here and we get the same reading. If we add another lamp to the circuit, connected again in series, the lamp also has a resistance of 1 ohm, then we are adding more resistance to the circuit so the electrons are slowed down. In this case, we get a reading of 0.75 amps, which means 4,818 quadrillion electrons are flowing per second. This is in series, so again, we can move the multimeter and we get the same reading. If we now connect the circuit with 2 lamps in parallel, both with a resistance of 1 ohm, and connect this to a battery of 1.5 volts, then in the main wire to and from the battery we get 3 amps. But on the branch of each lamp we get 1.5 amps. That's because the path for the electrons has split, so the electrons are shared with some flowing through lamp A and some flowing through lamp B. In this example, both lamps have an equal resistance, so the current is split equally. But if the lamps are of different resistance, then the current is split unequally. For example, if lamp A has a resistance of 1 ohm and lamp B has a resistance of 3 ohms, then in the main wire we get an amp reading of 2 amps. In the branch for lamp A, we get 1.5 amps, and in the branch for lamp B, we get 0.5 amps. As you can see, lamp B is dimmer because there is a higher resistance, so less electrons can flow through it. In both cases, the amps in the branches will add up and are equal to the total current flowing in the main wire to and from the battery. Now, I mentioned that lamp B was dimmer because the resistance was higher. If you remember, I also said that cables and lamps etc. are only rated to handle a certain amount of current. If it exceeds this, then they can burn out. So to restrict the amount of current that can flow, we can add resistors into the circuit or into part of the circuit. These act like speed bumps and slow the electrons down. Resistors are like putting a bend into a garden hose. The kink adds resistance to the flow of water, which reduces the amount of water that can flow out of the hose. Similarly, we can add resistors to the circuit and it slows down the electrons. For example, this LED is rated at 25 milliamps and 3.3 volts. But our battery is rated at 9 volts. So if we were to connect the LED to the battery, it will just...
These are the complete basics, what we learned earlier in the 6th and 7th classes, all the basics. What is current, how it flow. So that we are recalling here with that video. Now, when you start with the electric current, the first word in electricity we are discussing is electric current. Right? So electric current is nothing but rate of flow of charge. Rate of flow of charge. So what is meant by rate? Rate is nothing but time. That is mathematically I is equal to Q by T. First mathematical formula in electricity. I is equal to Q by T. So what is Q? Q is nothing but charge. Charge by time. Right? Just now I told how many number of electrons? One charge is measured in coulomb. The unit of charge is coulomb and time is second. So coulomb by second is also called ampere. So electric current is nothing but the rate of flow of charge or flow of charge per unit time. Mathematically given by I is equal to Q by T, where Q is called charge, T is called time. Q is measured in coulomb and time is measured in second. Our standard unit is named after scientist ampere. And this current is measured by using ammeter. So ampere is the unit, ammeter is the device used to record the current or measure the current. Clear? So 1 coulomb is nothing but so many electrons. Just now you have seen the video. Those many electrons when pass through a wire, you can call it as 1 ampere of current. Like that you can see in any electrical devices, how much current it is using and all. Right? So this is the first step. So as you know, when two charged bodies of different potential are connected with a wire, charges flow from higher potential to lower potential. So what is the meaning of this? For example, when there is a water is there, how water will flow? High level to low level, right or not? Tank, water tank to water tap it will come, high level to low level. Heat flows from hot body to cold body. Correct? Convention. Correct or not? So wind flow from high pressure to low pressure. Correct or not? Everything is common. Similarly, electricity also flows from higher potential to lower potential. That is positive to negative. Right? So the flow of electric charge per unit time is called electric current. That is this formula. Okay, there are two types of charges already you learned in lower classes in nature: positive charge and negative charge. Agree or not? So in an atom, both type of charges exist. The particles which are positively charged are called proton, and which are negatively charged are called electrons. You might have learned in the chemistry. Electrons are higher or lighter and relatively free, while protons are heavy and fixed in their position. Suppose if you see an atom, this is called nucleus, and this is called different orbits. So electrons revolve around the orbits because of their light weight, whereas protons will stay in the nucleus because of the heavy mass. So we cannot move the protons because they are heavy mass, whereas electrons are free, they can move, right? So the current flows mainly due to flow of electrons, and continuous flow of electrons is called electric current. So continuous flow of electrons is called electric current. That is this only. Mathematically, under normal circumstances, electrons and protons in atom are equal. So in generally, every atom contains same number of electrons and protons. That's why atom is electrically neutral. We call it as atom is electrically neutral. But whenever there is a transfer of electron takes place, then both bodies will get positive charge as well as negative charge. Okay? Where there is a more electrons are there, we get negative charge. Where there are more protons are there, body will get positive charge. So like that, we can get the two types of charges in a body. Right? Electrons, right? Direction of electrical current. So electrons flows from body that has excess of electrons to one of that has less number of electrons. The direction of flow of current is always opposite to the direction of flow of. So direction of flow of current is always opposite to the direction of electrons. It is also called as direction of conventional current. As per convention, what happened? I told current flow from positive to negative, higher potential to lower potential. But electrons will flow from negative to positive. That's why he's saying always opposite. Current direction is always opposite to the flow of electrons. Okay. From that only we are what I given definition already. 1 coulomb by 1 second is equal to 1 ampere. I is equal to Q by T. So current is nothing but rate of flow of charge. Rate of flow of charge is called current, which is 1 ampere is equal to 1 coulomb by 1 second. When 1 coulomb of charge flows through a conductor for 1 second, the current produced is 1 ampere. See, 1 coulomb contains this many number of electrons. How many? These many. 6.25 into 10 power 9, 10 power 18 electrons. 1 coulomb charge is nothing but 6.25 into 10 power 18 electrons. That many electrons makes 1 coulomb. More number of coulombs passes, more current is produced. So as per our requirement, we'll use the more and more current and more coulombs of charge. Right? So many more we learn in the coming session about the electricity. These are the only basics. So we learn more and more in the coming session about the electric potential, what is the potential difference, what is the electromotive force, what is Ohm's law, that is second synopsis. Okay. All these we need to complete in the coming 4 to 6 sessions till the examination test 6. Okay. So that's all for today. So define electric current and electric potential, of course, not discussed. Write about electric current. The rate of flow of charge, that is I is equal to Q by T, which is measured is nothing but coulomb, that is charge by time, coulomb by second or ampere. This is a home task for you. Next class we'll discuss about electric potential, potential difference, electromotive force. Then we have the Ohm's law, very important. And slowly we discuss about the effects of electric current also. Okay. So that's all for today. So thank you all of you. Have a wonderful day. Thank you.